Okay, so I wrote on the board that Wednesday will be your first quiz on this stuff. First quiz Wednesday on relations and functions. A linear relation is a relation whose plotted points lie on a straight line. A linear relation is a relation with a degree of 1. So what that means is that there is no power written. A power is an exponent. So we're going to be looking at equations that have y equals, and then there's going to be something involving x. And that x will not have an exponent on it, which means it is a power 1. The degree is the highest power for an expression. If there is no power written on the x, it means it's a degree 1 because the x is the same as x to the 1. So that's what it means talking about a degree of 1. A rate of change or slope is a rate that describes how one quantity changes in relation to another. If x is the independent variable and y is the dependent variable, then. So what that means, most equations are in the form y equals something involving x. Okay, Lucas? Most equations are in the form y equals something involving x. If you're going to evaluate that equation for numbers to try and get points that line goes through or that graph goes through, you're going to start with values of x because it's the variable inside the equation. You're going to choose numbers for x, you're going to put them in, work it out, and that'll give you your answer for y. Because you're starting with x, x is the independent variable. The other one, y, is the dependent variable because the answer you get for y depends on what you put in for x. That's where we get these labels, independent and dependent variables, from. So the rate of change or the slope can be found by taking the change in y over change in x. Another commonly used phrase for slope is that slope equals rise over run. The rise is how far upwards a line goes, from its very bottom point up to the top point, and that is the change in y. The run is how far the line goes horizontally, from far left to far right. And that's where the x values are changing, so that's the change in x. So we're going to be using this phrase a lot, that slope is rise over run. Okay, but the rise is the change in y over the run, which is the change in x. Rates of change can be positive or negative. This will correspond to an increase or decrease in the y value between two data points. When a quantity does not change over time, it is called a zero rate of change. So what that means, if the line is flat, it doesn't go up, it doesn't go down, it's perfectly horizontal. That's a zero rate of change. The rate of change, or the slope, corresponds to an increase or decrease in the y values as x is increasing. So that first graph shows a positive rate of change. As x increases, the values of y also increase. This graph slants upward. As you go left to right, it's rising. That's a positive slope. The second graph is a negative rate of change, or a negative slope, because as x increases, the values of y are now decreasing. And because of that, as you go left to right, the line is falling. It's going lower. That's a negative slope, or a negative rate of change. And that third one is a zero rate of change because the values of y remain constant. It doesn't go upwards or downwards as you go left to right. So again, this is a horizontal line. And the last one is undefined rate of change. The values of y are increasing, but x remains constant. There is no change in x value. It's a vertical line. So we say that has a rate of change that is undefined, or the slope is undefined. So you're either going to have a slope that's positive if it rises left to right, negative if it falls left to right, zero if it goes to the right but doesn't rise or run, it's horizontal, or undefined when the line is vertical. So The most common way to start graphing lines or any type of graph is by using a table of values. Remember that a linear equation is an equation with a degree of 1. The graph of a linear function consists of an infinite number of points on a particular line. The equation of the linear function defines the relationship between x and y for all points x, y on the line. A linear function can be graphed using a variety of methods, and the first one we'll look at is using a table of values. So to graph a line using a table of values, follow these steps. Complete the table of values by substituting the x values into the equation and calculating the corresponding y values. Again, the answer you get for y depends on what you put in for x. So because of that, y is the dependent variable, whereas x, the number you start with, is the independent. You can start with whatever you want for x. That's why it's independent. But the answer you get for y depends on what you put in for x. So y is dependent on x. So you're going to complete the table of values, and then we'll put those points on a graph, and then we'll draw a line through the points to get the graph of our line. And at the end there, it says place arrows at the end of the line to show that the graph continues in that direction forever. So in this first example, we have a linear equation. This is a first degree equation because there are no exponents on either the x or the y. It's y with no exponent, which really means it's y to the 1. Same thing with x. And whenever you have an equation of degree 1, that means that it'll be a line. So you know just by looking at this equation that it'll be a line because it is a first degree equation. So in this case, the table of values is set up, and they've also given us values of x to choose to put into the equation. So the first x value we have is -2. So the equation says that y equals x plus 2. We take our x value, which in this case is -2, and we add 2. And when you add those together, you get 0. So that gives us the ordered pair, -2, 0. When x is -2, y works out to be 0. So on the graph, that's that point right there. X is -2, so you go 2 to the left. Y is 0, so you don't go up or down. The next point we're going to generate is when x is -1. So I'm going to let x equal -1 in the equation above. It'll be -1 plus 2. And -1 plus 2 is +1, and that gives us the point -1, 1. So -1, 1 is right there. That's that point. The next point we're going to do is when x is 0. So we'll let x equal 0 in the equation. And 0 plus 2 is 2. This gives us the point 0, 2. That's that point right there. The next value of x is +1. So we're going to let x equal 1 in the equation, so it'll be 1 plus 2. 1 plus 2 is 3. This gives us the point 1, 3. That's that point right there. Next x value in our table is +2. When x equals +2, y, which is defined by x plus 2, will become 2 plus 2, which is 4. So that's the point 2, 4. And finally, when x equals 3, y will equal 3 plus 2, which is 5, and this is the point 3, 5. When x equals 3, y equals 5, so that's that point right there. All these points line up, which is what we needed to see. By looking at the equation, we know that it's a first degree equation. There are no exponents on anything, which means they're power 1s, and whenever it's a degree 1, the graph will be linear. So all these points needed to line up, and they did. Now we can draw a graph going through them all. And as it said, we have to put an arrow on both ends of that line to show that that pattern continues forever. There are infinitely many points that would work for this equation. We found 6 points that work, but there are infinitely many more that could work. You can start with any value you want for x. Plug it in, you'll get a corresponding value for y, and those points would all be on this line as well. Now, technically, you only need 2 points to graph a line. My advice, if you don't have a table of values set up for you, and you're going to make up your own, do at least 3 points. Because if all 3 points line up, that means you've probably done things correctly, probably. If only 2 of them line up, there's a mistake somewhere, so you got to go back and check. Technically, you only need 2 points to draw a line, but we're always going to find more than that just to make sure that we're on the right track. All right, the second equation, that is a linear equation because there are no exponents on either the x or the y, meaning it's a first degree equation, Hannah, and that means that it'll be linear. The equation says that y equals 1/2 x take away 2. Whatever values you start with for x, your first step is to take half of it, and then you'll subtract 2. And because of that, you can see that all the values of x in this table are even numbers. When you take half of them, you don't get a decimal. It's not saying it wouldn't work if you did start with an odd number, it's just that you'd have a decimal involved. Okay? Easier not to have that. So sometimes you're selective on what your x values are that you start with. Again, in this case, when you look at the equation, whatever number you choose for x, your first step is to take half of it. So that's why we start with even values of x. So also notice in this case here, you don't have that column where it shows you're putting in the x value each time to get the y value. You can still do it on the side here. For example, the first point is when x is 0, y will be half of 0, take away 2. Half of 0 is 0, take away 2 is negative 2. So that gives us the point 0, comma, negative 2. When x is 4, to find out what y is, we take half of 4 and subtract 2. Half of 4 is 2. Take away 2 is 0. This is the point 4, comma, 0. When x is 8, y is found by taking half of 8 and subtracting 2. Half of 8 is 4. Take away 2 is 2. So this is the point 8, comma, 2. The next point we'll get by letting x equal 12. So we take half of 12 and subtract 2. Half of 12 is 6. Take away 2 is 4. So this is the point 12, comma, 4. And then it switched to some negative values of x. First being negative 4. So half of negative 4 is negative 2. Take away 2 is negative 4. So that's the point negative 4, comma, negative 4. Half of negative 4 is negative 2, and then you're going to subtract 2 to get negative 4. Now, you can do these on your calculator as well. So I can go 1 over 2 for a half times negative 4 subtract 2 gives you the same answer. So you can always use your calculator to help you get some of these y values or to check the values that you did get. So the last one we have here is when x is negative 8. Half of negative 8 is negative 4. Take away 2 is negative 6. So this is the point negative 8, comma, negative 6. So we have 0, negative 2. 4, comma, 0. 8, comma, 2. I don't really have room on this graph for the point 12, comma, 4 because my x value only goes up to 10 on this graph, so I'll skip that one. The next point to have is negative 4, negative 4. And the last point I have is negative 8, negative 6. Looking at all these points, they all appear to line up. So we should be able to draw a line through them. And actually, I'm off on that one point. Let me just check. I think that's the point -4, -4. Yeah, I graphed it wrong. I put it at -5, -4. Should have been right there. Right, so we put arrows on the ends of our lines to show that that pattern continues forever in both directions. So I couldn't really graph the point 12,4 accurately just because I ran out of room, but I mean, I could kind of guess where it is. 10, 11, 12, 1, 2, 3, 4, approximately right there. And if we extend that line, it would go through it. It might be off just a little bit, something like that. But that's fine. Again, technically, you only need 2 points to draw a line. We're always going to find more than that just to make sure that we've done things correctly. So in this case, we're not given x values to start with, so we need to choose our own. Okay? And there really is no right or wrong numbers to start with, except you want to make sure that you end up with points that you can put on your graph. I wouldn't start with an x value of +20 because I can't put that on my graph. It only goes up to +10 on the x-axis. Same thing, I wouldn't start with -12. It's not on our graph. Okay, so a good place to start with would be -2, whoops, to +2. And in this case, we'll have room for one more point. So whatever numbers we choose for x, the equation says that we multiply the x value by the -2 in front of the x in the equation, and then add 1. So in this case, -2 times -2 is +4, plus 1 is 5. This is the point -2, 5. The next point is when x is -1, so it'll be -2 times -1 plus 1. +2 plus 1 is 3, and we have the point -1, 3. When x is 0, -2 times 0 plus 1. -2 times 0 is 0, plus 1 is 1, and we have the point 0, 1. When x is 1, it's -2 times 1 plus 1. -2 times 1 is -2, plus 1 is -1. So that's the point 1, -1. When x is 2, it's -2 times 2 plus 1. -4 plus 1 is -3. 2, -3. And when x is 3, it's -2 times 3 plus 1. -2 times 3 is -6, plus 1 is -5. I've got the point 3, -5. So -2, 5. -1, 3. 0, 1. 1, -1. 2, -3. And 3, -5. All those points line up. Right, and now we can draw our line and put our arrows on the end to show that that pattern continues. Note that this line has a negative slope because as you go left to right, the line is falling. If we look at the first two examples that we did, they both have a positive slope because as you go left to right, the line is rising. I want you to notice something else. In this first table of values, we started with an x value of -2, and then we added 1 every time. After -2, it was -1, then 0, then 1, then 2, then 3. We added 1 every time. And look what's happening to the y values in this case. They're going up by 1 as well. Now, it's not so much that they're going up by 1 that's important. That's just a coincidence that both x and y are going up by 1. But what is important is that y is going up at a constant rate. In order to have a line, y must go up by a constant rate as x goes up by a constant rate. So if we look at the next one and we just kind of key in on these points where x is going up at a constant rate of 4, note that the y values are going up by a constant rate of 2. As x rises or changes by a constant value, y changes by a constant value as well. And they're different, right? X is going up by 4, y is only going up by 2. But what's important is that as x increases or changes by a constant rate, y changes by a constant rate. That must happen to have a line. If the values of y are not going at a constant rate, you won't get a line. On this last one, same thing. X is increasing by 1. The y values are decreasing by 2. And because the y values are decreasing, that's why we have a negative slope. The line is falling as you go left to right. So for number 4, this is a line because there's no powers on the x or the y, which means it's degree 1. Whenever you have no powers on the x or y, it's going to give you a line. And if we look at our equation, whatever numbers we have to choose for x, we're going to multiply by 3 and divide by 4. So to avoid any decimals, I'm going to use numbers of x that are divisible by 4. For example, I might start with -8, -4, 0, 4, 8, and 12. Whatever numbers I choose for x, the equation says you have to multiply that number by 3/4, which means you're going to multiply by 3 and divide by 4. So I've chosen numbers that are divisible by 4. And so we can use our calculator to help us here. We've got 3 divided by 4 in brackets times my first x value is -8 plus 3. That gives us a y value of -3. So I've got the point -8, -3, which -8 comma -3 is right there. So there's that point. The next value I have for x is -4. So I'm going to have 3/4 times -4 plus 3. That's 0. So that's the point -4 comma 0. 1, 2, 3, 4 comma 0 is right there. The next x value I have is 0. And 3/4 times 0 is 0. Anything times 0 is 0. Plus 3, though, gives us 3 as the answer. So that's the point 0 comma 3. When x is +4, and you plug it in, you get +6 as the value. So that's the point 4 comma 6. 1, 2, 3, 4 comma 1, 2, 3, 4, 5, 6. So again, all these points are lining up. When x is 8, you get a value of 9. So that's the point 8 comma 9. 8 comma 9 will be there. And I'm not going to have room for that next one. because you see as x increases by 4, the y values are increasing by 3. So that pattern would continue. I don't actually have to use my calculator for this last point because I know that the x values will increase by 3. And 3 more than the previous, I should say the y values increase by 3. So the last y value is 9. The pattern continues. The next one will be 12, which again, I don't have room for on this graph. I could estimate where it is, but I don't need to do that. All the points that I do have line up. So there's our graph. This one has a positive slope because as you go left to right, this line is rising. Okay, so we'll stop there. I'll hand out the assignment. This one is going to be due for marks. So you got to do it and hand it in. And remember that our next quiz is December 7th, Wednesday, on